Hi, I'm Pagata12, and in this one we build Mobius SOP. So this will be a little bit different than the one before. And as you notice here, the texture is super clean, no diagonal, no lines, nothing. And yeah, the secret is to be consistent with the index of the points. So in the end, we'll replace this grid points with some points that we have here. So yeah, this can go either with this manner where I have the shuffle done in tops, and by doing this you are limited by this length, which is 32,678, but yeah, you can use the top two out from here. So then you can go with much more points, but yeah, that will be a little slow till it gets all the points. Okay, so yeah, let's build this from scratch. Okay, so again, we need a semicircle. Okay, so we build a semicircle in the center. Okay, and we need to offset that and then place it all around, right? But in order to get a Mobius, in the time I rotate the semicircle like this along the y-axis, each semicircle needs to be rotated along z-axis, let's say, okay? Because after one circle, I'm hoping that I can close those semicircle, and actually it's needed two loops. Okay, and yeah, let's build this. So obviously we need a constant chop. Okay, where we go with one single resolution, and that would be how many points I have on the initial semicircle. Okay, that would be a width of the Mobius band. Okay, and yeah, let's use a ramp for this. Okay, here resolution, and let's take 64. Okay, and this one should be 1 by 64, and yeah, let's go with vertical, and let's drag this actually, because I might lower this down a little bit to 32 in order to see the point. So I will go with the nearest pixels as much as I can to actually see the points. Okay, so I have this, as in previous tutorials, we want to transform this one-dimensional linear ramp into directions into a plane. Okay, so we'll transform this 1D into 2D, two-dimensional texture values. So for this we use a mod here, and again we only need half of the circle, so we multiply this with mod.pi. Okay, let's set this to nearest pixels. Okay, and now we use the function to get the, so on x I have cosine, so let's go here, go with the cosine radians, and this should be, this one actually should be 32 mono. Okay, and another one for the sine, which is y-axis, so sine. Okay, now I use a reorder like this. This texture has to be 32 RG. okay, and yeah, let's have second input for the green, okay, and now we have that semicircle, which yeah, it's placed wrong, and we know now that if we switch those two, now we only need to flip this on y-axis, okay, so now we good. So we have this 32 points semicircle, okay, and yeah, we know how to offset to 1 and then place it all around the y-axis. We know how to do that. What we need is to always rotate each of the semicircle. That there will be, maybe let's go double. So I have this 32 resolution, okay. Out of here I use a fit, okay, where I go 32 multiplied by 2. Let's go with the nearest pixels and fill, okay. So I have this texture which represent the 64 semicircles, okay. So in order to get each of the semicircles rotated a little bit more than the one before, okay, I need to use rotation, okay. So and I will show you what I don't really like to point transform. So let's imagine I will have 8 points. So let's use a constant, okay, and this constant is 8 by 1, and by doing 1, 0 and 0 here, let's go with 32 RGB, okay, that means we have 8 points in a 1, 0, 0, okay. So I would like to rotate each of the points. The first one will stay there, so first one will take the rotation 0. The second one will take a certain amount of rotation. The third one double, okay, actually, and so on till the last point will reach a desired directions, okay. So if I want to spread those points by rotating all of them to cover the arc of the circle from 1, 0 to 0, 1, okay, that would be 90 degrees divided by 8 points and so on. And yeah, I was hoping for this point transform to do that. So view as image and display color, okay, right. Now if I transform this along the z-axis by rotate, okay, I'll have one single value, okay, and I'm supposing if you use some chop transform here, or I don't know, maybe you can do it, okay. For this particular tool, which I believe is super important, okay, we will build later on after we get familiar with the matrices and so on. We build our own transform tool, which actually can take a lot of things and can rotate each pixels, each point in space separately, okay. But till then, we need to trick this rotation, and to trick the rotation, it's difficult, okay. But in this particular case, where we have a circle, I found out a little trick, and I would love to share with you, as I was glad to find this trick. So let's imagine we have the axis, okay? And the circle we are starting with, it's like this, okay? And let's place some points, okay? So maybe we have here a point, okay? Like this. So yeah, let me, I don't know if I'm consistent with the number of them to be equal from here to here, but yeah, just for explanation. So we have those points, and you notice in particular these end points are not on 0 or 1, as we use a ramp here, okay? And this ramp doesn't go to 0 or 1 and stay in between, okay? And this is crucial right now, because you can limit that ramp and touch 0 and 1, but in this case we don't want that, okay? So the problem here, how we rotate those in this manner, okay? Like rotating along z-axis, which is actually not visible here, okay? And the trick that I found is for every semicircle except the first one, okay? So let's imagine we take the second semicircle, which need to be one step rotated. We'll do this trick. So imagine we take this point here and we flip it here, okay? And for the next semicircle, we take this one also and put it here, and so on. We'll flip all the points till my arc semicircle will come here in this place, okay? So after I finished all the points, 32 or how many they are, if I flip those points in order, then in one go I can be in the mirror, and so I need another flip, okay? So while I'm here, then I flip again. Let me pick another color. So this one then will be flipped again, okay? So this semicircle will come here and then here, and you see that will be a perfect match, okay? Now let me show you something that might happen if you do that, okay? So we have the axis, okay? And here in our file where we flipped that, okay? So we flipped, this is our circle. This right here is index 0, 1, 2, 3, and so on, okay? Now, by taking, I don't know, let's imagine we have those points here, 4 and 4. And by placing this point here, okay, this placing of any point, it's so easy. We just multiply with -1, so it's super nice, okay? But by doing this, that means the index 0 will be last, okay? And if we were to connect the points according with the index, then will be something like this, from here to here to here, and so on. So yeah, the arc of the circle, the order, it's really messy, okay? Yeah, let's see. We will solve that. So we need to multiply in step each of the point starting from the bottom, okay, with -1. Also, let me see this as an image, okay. Also, you notice by switching the points for one semicircle, we get here in this position. So obviously we need to go once again, okay. So this is why this texture is double in length, okay. Now to finish the rotation, okay, in only one step, we use this double texture, okay. So half of the texture would be for the mirror semicircles, okay. So let's do that. We use a constant, okay, only 1 pixel. We need to split a rectangle in two, okay. So we use 1 by 1. This has to be 32 mono, okay, and yeah, the value it's 1. We are good. And now we use group, and let's see, to the right, 2 pixels to the right, and instead of repeat we go with 0 and nearest pixels, okay. Now this texture is 1 where I have white and 0 where I have 1. And what I want to do is multiply this one as half of it stay in place and another one it's mirrored, okay. So I need to transform this texture, rearrange, okay, from so where I have 0, I need to have -1. It's like this. And now let's multiply these two. Okay. Now, if we see them, we have a fully circle, but half of so half of this texture, it's those circles, and the other half is those circles. And now we need to solve the flipping, okay. And for that, obviously, if we go here, let's say this row remains the same, and the second row I have a single pixel here with -1. The third row I'll have 2 pixels, you know, on any column. So let's do this by a ramp. So I'll have a ramp, actually 32 by 32, okay, and this is 32 mono and radial, okay. Now I would like this line to start from this corner and go here. And so I need the position to be -0.5 and -0.5. Okay. And now we want to rotate this like this. And yeah, here it's 1 divided by 8. Okay. Now we don't need anti-allies, and let's see. Okay. Now, yeah, this is a bit confusing, you know, but we can use a mod here. And let's go with round, okay, and let's check this. So the first pixel in a first column, it stays the same. So after this, we start to flip the bottom points, okay. So exactly like beneath here, this is 0, 1, and I would like to rearrange this with a mod. Sorry, not mate, So mod like this, and range from 0, 1 to -1. No, wait a second. So yeah, 0 it's 1 and 1 it's -1. Yeah, like this. Okay, and now obviously here we have 32 by 32, and we need to apply this step on both of the halves here or here. Okay, and that means we can use a group and fraction group right 2, and we have this texture. Okay, and yeah, let's multiply this. Okay, and this should be nearest pixels. Okay, what we have, you can't really see, okay, what it's here, because every time we flip a point, that one goes where some other points goes, and so you can't see any difference. Okay, but yeah, this is what we need to make, so we are good till here. Now remember, when we flip a point, that one it's lose the index. Okay, so we need to set the index, to reset the index to start. For example, each index has to start from here, from the first white pixel, and go to the top. But by doing this in tops, always the 0 index is at the bottom. So what we need to displace this texture. So we can use a ramp. It's very easy. So we use a ramp here, and this has to be double this size, okay, by 1. Okay, and let's see now. This has to be 32 mono. Okay, and now we displace. Okay, so first of all, there is no displace on X. Okay, so it's 0 here. Horizontal source, or yeah, we can leave the 1 there and say here no. Displace for horizontal. Vertical, it's taking the blue. It's okay. It's the same as green and red here. And let's see. Repeat. Okay, I will. Okay, now this line there should be at the bottom. Okay, so let's see how can we do this. Okay, the easiest way is just to transform and repeat, but yeah, there has to be a way. There has to be a way. Okay, it's not that. Let me change here a little bit. 64. Okay. Maybe if we use here, I will go and check back the file that I have, because yeah, I always have this in a strange manner actually. So oh, okay, yeah, I see what's here. So let's go back. So here we need to, you see, if we change this value here, we are good. So we're gonna do like 1 divided by this by 2, and now we are good. Okay, and yeah, now what we need to do is place those circles around the y axis, and yeah, obviously we offset before. So let's go with a mod. And first we set the radius, the first radius being maybe half, 1 divided by 2. Okay, and then we need a mod. Okay, and I want to add 1 only for the x-axis, so I will mask the blue and green, and here I go with 1. Okay, and yeah, all the circles are here. Okay, and this is radius 0.5, and now I want to solve the rotation. Okay, and we do the same. We take this. Okay. Oh, we need a ramp, so let's use a ramp which takes this as an input, so we have the same resolution. This ramp should be 32 mono. Okay, and now connect it here, and again this time we need to go fully circle, so instead of mod pi we multiply by 2. Here we multiply by 2. Okay, now we good, and yeah, we need 2 reorders here. In first one we colored red, and we take the red, and this should be mono, and in this one we take the green and we color green. Okay, now the x coordinates we multiply with this texture. Okay, and we add this only for the y, so I'll mask red and blue. Okay, now let's see. So okay, it's something wrong, and I know what this is. Here, this reorder it takes 0 for green, and this goes into the third, and this goes into first one, and yeah, this is RGB. Okay, and yeah, let's take input 3 here. Now we are good. So now the Mobius is it's good. So now we use this this null, and let's place those points. Let's replace points of a grid with those points, and for that let's see. So we go with top 2. Okay, and I plan to take all the texture, but first let's put a shuffle here, and goes for sequence channel by name. Okay, and now group full image. Okay, this one we don't need alpha. Okay, and those points, let's also use a grid. So a grid here, 2 by 1, and let's see, we use this value for the rows, and for the columns we multiply this by 2. Let's see now. This is clean, and okay, now chop 2, and I'll grab this and take R, G and B. Okay, now and compute normals, right? Now let's have a look. Okay, now you see I have this Mobius, and yeah, a little problem here. As I told you, the points doesn't start from 0, so this is where this gap comes from. Okay, it will be smaller and smaller if we increase this number here. So if we go with 1 to 8, the gap, it will be smaller, but we need to solve that. Okay, so what bothers me more than that little gap is the cutting wall. I would like to close this. Okay, so for this what can we do? So here we have the texture. What can we do is use a transform. Okay, and I would like to set the pivot to 0, 0. Okay, and I would like to transform this with a smaller value than 1, as all the values will go down actually, and leave the 1 pixel for completing the loop. Okay, so yeah, and for the scale we use actually this resolution. So scale on X is 1 minus, so 1 minus, sorry, 1 minus 1 divided by 2. Okay, and let's see. Actually, I will lower this down to see that pixel. Okay, so let's go here, and for the tile we go with repeat. Okay, now maybe here we leave nearest and not interpolate pixel in the input smoothness. Okay, so now we solve this gap, but I would also like to leave the not a column as here. I will leave the a row. Okay, at the top of the texture the row will be exactly like the one at the bottom, so I need to transform here and by this, so now multiply with 2. Okay, and you notice my Mobius, it's closed now. So yeah, this is how you build a mesh. Now I was convinced maybe that this is the workaround, and there's no optimization, or there's no nothing to do. Okay, and then I took a closer look on the topology of a mesh, and it's looked like it's squeezed, you know. So those polygons, which are more like a rectangle than a square. Okay, and this is because in a torus, let's have a look here. So in a torus, you see, for this circle in a section we have 20 points, and for the whole torus we have 40 points. Okay, now we don't use a circle in a section, we use semicircle, and we have, instead of 20 points, we have only 10. So the ratio between the rows and columns for the Mobius band, it will be 1:4, not 1:2. Okay, this 1:2 ratio was very helpful for us to flip the points and trick the rotation. Okay, but yeah, I would like to have this perfectly mesh. Okay, so what we do now? Okay, first of all, let's try to correct the ratio, and here I will go with for this fit, I will go with multiply by 4. Okay, everything gets broke, doesn't matter, and we are good here. Also multiply by 4. Okay, and yeah, let's see, here it's 4. Okay, and yeah, it's a little bit ugly now, but yeah, we'll fix it. And here in transform, we need to multiply by 4. Okay, maybe not multiply, we divide by 4. So let me see if I put some parentheses here. Oh, so yeah, divide if there's no parentheses. Okay, now 1 minus, this seems good, and also here is multiply by 4, and yeah, now we kind of good. Okay, let's take a look on the surface now. Now they seems more like squares, but you see, it's strange, and because we flipped we flipped those points. Okay, there's more needed to solve this. Okay, one way is let me show you. One way is let me make some room here. I will move this here. Okay, so let's imagine we flip 1 point. Okay, so we have a couple of points here. We go with 8. Okay, we flip this one here. Okay, if we go like that, in 2 loops we get to the starting position. We need to make 4 loops, as the ratio between rows and columns is 1:4. Okay, what we can do is takes those pixels here, make the average, we'll get the center line of this, and yeah, it might not stay on the circle, but then this vector from here to that center, if you normalize it, you get the correct point. And so yeah, that work, but I would like to show you another method, which is I love it. So let's fix these points. Okay, let's have a little room where, let me think a little bit. So I believe here, right? So here we actually insert a null and collapse selected, and we can name this smooth, right? So nobody can stop us. Okay, so this is smooth. Now let's see. I want to translate this texture. So, okay, to 1 pixel to the right, and then to the left it's -1 pixel, and then I want to make the average, so I use a composite. Okay, I make the average of those two, and another average of those two. Okay, and now another average with the results. Okay, we have, okay, and this one. And let's see now the mesh. The mesh now it's perfect. Okay, we have here, let's see the, yeah, so we have here a little error, and let's go in transform and repeat. Okay, now this is a much better mesh for the Mobius. Okay, what else we can do here? So I tried to scatter some points along this surface, and while going for the roundness of the Mobius, it's nice and fine. We have plenty of points there. If I would like to scatter some points on this straight band, the cut, right? I can't, because I don't have points there. Okay, so what if I build a mesh that it's uniform on that cut also? Okay, so yeah, let's see how we do that. So obviously we need way more points. Okay, and let's see here. So here we have the top and the bottom. Okay, and I would like to group. I would like to group the first row. Okay, so let's see how we do that. Group from bottom. So let's go like this. Okay, so from bottom it's good. I need from bottom how many pixels? I have 32 minus 1, I believe. So I go here with 32 minus 1. Okay, so this is the first row. Okay, the second row is 32 minus 2. And here would be minus 1. Okay. Now, this is the edge of the roundness of the Mobius band. Okay, and if we subtract them, we get the vector direction. Okay, and we can multiply that vector direction with the ramp having as many pixels as we want points there. Okay, in order to stay clean and nice, I will judge like this. If on a semicircle, which is pi, I have a number of points, in this case 32, that means on that cut, which is 2 radius, okay, I'll have 32 divided by pi, multiplied by 2 then. Okay, because there are 2 radius in that cut. Okay, so yeah, let's have this. So we need to subtract this end, because the top row is the bottom. Okay, actually, so this one I subtract out of this one. So let's go with subtract. Okay, so this is the vector that I need to multiply with something. Okay, so let's use ramp. Okay, and for this ramp would be 1 by, and now let's see, 32 divided by mat dot pi okay, and this has to be vertical. Okay, but it's multiplied by 2. So yeah, for the curvature we have 32 points. For the straight cut, which is 2 radiuses, we have 20. Okay, so let's use a fit here, and this has to be this resolution multiplied by 4, and here for the resolution on hash we need this 20, and we copy this expression. Okay, when we don't have we don't have always integer results, and we can go here with math dot seal, and we take this. Okay, now it's 21. It's much better. So yeah, let's grab this texture and use it here. Okay, and we go with fill and nearest pixels. Okay, now if we multiply those two, we have this, and let's see. Yeah, this is not looking so good right now, but yeah, let's see. Okay, we'll just a second, because I need to, yeah, I need to check that much better. So I subtract this one. Okay. Oh, so then I need to multiply the result. Okay, not to multiply, the add to where I have this second row. Okay, now for that let's wait a little. So I make some room here. Okay, now this subtract, it's good. What I need to use another group. So I use another group where I would like to cut out this extra pixel from the top. Okay, so let's see how we do this. 1, maybe 2, no, 32. So 32 minus 1. Okay, and I would like to group again, and this time let's see, we have 32 points plus 20, so top, bottom, let me check how this goes. So I will put 0 to see here. So if we go minus in the opposite direction, right? So then I'll have, yeah, this is not good. So from the top. Okay, 0. So yeah, we go from here. Let's see. Yeah. So this amount should be 32 plus, so I have this expression, okay, plus this one. Plus, okay. And now we need hold, okay? So this this is 20 rows of the topper line of points on a curvature, okay? And above this we need to add this texture, but let's have this texture also ready for adding, okay? As I need to add this texture only here at the top, okay? So that means I need to use a group here and go with the bottom and the same value, but I believe it minus, let me check, minus, and this is 32. No, actually it's minus 32. And 0. 53, 53. Now we are good. So yeah, I make sure everything is nearest pixels. And now let's add those together. So add. Okay. And yeah. Yeah, it's good. Maybe we need to change also here. So this is 1 to 8. Let's copy this expression and go for the grid rows. Oh, what's this? I like this. I never saw it. I like it. So yeah, I don't know what this is. And I believe we need a different direction. So I will switch those two. Okay. So yeah, now we're good. And you see, we need to solve this little gap, which let's see how we solve it. Okay. So what I believe will solve this ramp doesn't go from 0 to 1, and so yeah, from that extreme of the curvature, okay, I need 0, and to actually touch the other extreme, okay, I need 1. So we go here with limit and normalize, and yeah, now we have a perfect mesh Mobius. So yeah, this, and yeah, this was the trick that I found in trying to bypass any rotation required. And I found this method works for some other shapes, okay? And yeah, some particular shapes, round and stuff like that, they can be done like this. And yeah, I really hope you like this. Thank you so much for your support. Thanks for watching this, and see you in the next one. Bye.